Okay. So kind of a tricky first, pass. Stay with me. Right? But it's better if you go through the practice test on your own, right? Because otherwise the danger is when I go through it with you, which we'll do, right, is that, oh, well, that sounds reasonable. It'll all sound very reasonable when I say it, but it's a different thing when you are sitting in the test and you have to come up with the stuff on your own. And so that's why I make you do it beforehand, so that you know how you thought about it, and then you can correct those. Okay. I know I don't even like to do things wrong because I'm afraid that I'm gonna learn the wrong way. But it is the best way to learn, right? To see how you thought about it, and then really analyze why you approach that problem that way, right? Or maybe why you couldn't even get started, right? That's fine. So, test number 1. In case this is news, it's on Monday, right? I better send it to the printers. Okay. So today what we're gonna do is just go through the practice test. As far as the format of the test, what you can expect to see is something like this, right? So the same types of questions, I'll even keep them in the same order, right? Just so I'm not throwing you guys off. So it'll feel familiar, it'll just be new numbers, right? New problems to solve, but the ideas are all gonna be the same. And so I'm not trying to get you guys, but I will warn you that this is typically the worst test. Maybe people are kind of laid back and thinking it'll be easy, and then all of a sudden it's not. Or I don't know what happens, but this test is not a good test for people. So if you do well on this one, then top notch. Right? But if you don't do well on this one, the others will be better. So you win either way. So what I'm gonna do, oh, does anyone need a copy of the practice test? I have a few more copies up here. You can come grab one if you need it. Oh, I thought that was me. I thought I turned everything on and off that was supposed to go. I'm gonna put this here. Yeah. So this is practice test number 1. I would say that this is maybe the hardest question on the test. That's why I like to put it at the front. So either you can ignore it when you get to the test and just wait till the end maybe, or you can just tackle it right away and get it out of the way. Either way, it's at the front. Yeah. So we've got this linear programming question, right? So it's nice to know what section we're talking about here. So here I'll make a note that this is linear programming. Just in case you wanted to refer to the textbook, see what's, maybe read up some more on it, maybe look at our notes from class. Yeah. So we've got this P that we want to maximize, and we've got these conditions. And so we had a bunch of steps that we followed, right? And so what do we have to do? Well, the end goal is to graph these conditions on our graph, figure out the feasible set, find all the intersections, and then evaluate P at each of those intersections. But first, to graph them, that gets a little tricky sometimes, right? So what I do is I just solve each of them for Y, and then I can just find 2 points on the line, draw those points, connect the lines. You can see why I like this question on the test. Makes you do a lot of stuff. And once you get the hang of it, it's pretty fun. So what I'm gonna do is I'm gonna call this equation 1, this equation 2, and we have this little y has to be less than 6. I'll call that equation 3. The x less than or greater than 0 and y greater than 0, that's just forcing you to work in this quadrant. So you can actually just ignore that. Right? Those are always going to be there, but you can ignore it. So we'll only work with this equation 1, 2, and 3. Okay? So equation 1, you know what? I'll write them out as kind of steps so that you can learn the steps. Okay? So step 1, solve equation 1, 2, and 3. 3 is already solved for y, but we'll do that one because it's easy for y. So equation 1 is going to be 2x plus y. And you know what I'm going to do? I'm going to swap those inequalities, right? The less than or equal to. I'm just going to make them equal signs. And you can do that too. And then we can put them back in at the end. Maybe we won't even. It's just saying everything has to be below this line is all it's saying. So we can use an equal sign. That's nicer to deal with. And don't worry, it is recording. I've checked it 3 times now. This would be a bad one to miss, I think. So 2x plus y is 16. Solving for y, we get y is 16 minus 2x. That one's okay. How about equation 2? Equation 2 says 2x plus 3y is 24. Solving for y is a little bit messier. So we have 3y is 24 minus 2x. So then y is 24 minus 2x over 3. So 24, yeah. So we can rewrite this as 24 over 3 minus 2 over 3 times x. Mm. 24 over 3 boils down nicely to 8, but 2 over 3, we're stuck with this nasty fraction. 8 minus 2 over 3x. That's okay. And then as a little reward, equation 3 just says, well, y has to be less than or equal to 6. So we're going to draw a line at y equals 6, which is just a straight line. Done. Solved it for y. Okay. So we've solved all these for y. That's good. Okay. Step 2. What I'm going to do now is I'm going to work towards drawing these lines on the graph, right? But I'm going to find 2 points on each line so I can plot them. So step 2, find 2 points on each line to plot them. Okay. This is the part where we take equation 1, for example. Equation 1 was y equals 16 minus 2x. And we pick values of x, and then we solve for y. You're going to pick convenient values of x, right? Values of x that you want to work with in this equation, but also you want to make sure that you're staying, because these are the x's that you have to draw with, right? So you don't want to go beyond these x's that I've given you, right? Because you have to draw it on this graph. So you want to pick an x between 0 and 14, a nice number. Okay. And so I like 0. X is 0 is always nice. That's my go-to. Okay. So I'll start there. So then y must be 16 minus 2 times 0, which is just 16. So then in terms of xy, we're at 0, 16, right, for that point. And you don't have to draw those or write down those points if you don't want to. I just like to have them nice and condensed. Okay. What's another nice point of x that we could use? We could get sneaky and say, well, if I pick 8, that makes it nice, right? So I'm going to pick 8 and say, well, y is 16 minus 2 times 8. That's 0. Sneaky, but legit. Okay. 8 and 0. Any value that you pick is going to give you a point on the line, right? So I'm just being creative. Okay. How about line number 2? Line number 2 is the one with a fraction. Y is 8 minus 2 over 3x. Doing the same thing, we have to find 2 points on this line. So y is 8 minus 2 over 3x. Of course, I'm going to pick 0. Okay. So y is 8 minus 0. Oh, you know what? Do it properly. Minus 2 over 3 times 0. It's 8. Here, I'm going to pick a nice value in the sense that it's going to be divisible by 3, right? Because my x has to get divided by 3. So if I pick something that isn't divisible by 3, it makes it really difficult, right? Because then you have to keep the fractions and you have to figure out what that is. And so you want to try to eliminate that 3. And so just to spice things up, we could use 3, 6, 9. But you know what? I'm feeling crazy. Let's go for 12. We'll see why in a sec. If we do y is 8 minus 2 over 3 times 12, that's 8 minus 2 times 4. What? I know. What you could do, right, is you could say, well, right, to figure out which one you might want, here, oh, red. You could say, it's sort of showing. Well, I'm going to force y, so y is 8 minus 2 over 3x. If you want to force it to be 0, right, then you can force it to be 0. Right? Force it to be 0, and then solve for x. Right? Kind of working backwards if you want to. Again, you don't have to, right? You could have picked 3, 6, 9, 12, etc. So 8 minus 2 over 3 times x. Moving the 2 over 3, you're going to get 2 over 3x is 8. And then you get x is 8 times 3 over 2. So x must be 12. So you could force it that way. But like I said, anything will go here. Step 3, right? Yeah. Notice I didn't do anything with y equals 6 because y equals 6 doesn't care what x is. It's just always going to be 6, right? So it's just a straight line at 6. So step 3, you're going to plot the points and draw the lines on the graph. So plot the points and draw the line or lines on the graph. So what I'm going to do is I'm going to just copy this guy so I have it closer, so I'm not scrolling up and down all the time. You guys have it in front of you, so it's easier. So I forgot to summarize my points here. 0, 8, and 12, 0. Okay. The important thing is that we keep track of which points belong to which lines, right? And so I'm going to do line 1 first, and then do line 2, just so I'm not drawing points everywhere and then trying to figure out which one belongs to which. Right, so I'm going to do 0, 16, and 8, 0. So 0, 16 is when x is 0 and y is 16. And then what was it? 8, 0? Nice. So now x is 8 and y is 0. So that's down here. Just makes it nicer when you can work on the axes. So now, how do we draw these? Looking around for a straight edge. It's okay. Just in the test, you can even just kind of gently roll the paper over. Use that as a straight edge. That works perfectly fine. The edge of your calculator, your student card. I don't know. Find a straight edge. So now we'll connect these. Hopefully it drew. It didn't. Okay. Is it drawing? Can't see. There. Aha. That is a relief. So what I'm going to do is I'm going to say that this is line number 1. Right? Just put a label on it so I don't get confused later on. It happens. And this is where y is 16 minus 2x. Okay. So now we've drawn the line 16 minus 2x. Good. How about the second line? I'll change colors. You probably won't be able to tell now, but later when you look back at it, you can. First point here was 0, 8, and then 12, 0. So 0, 8, x is 0, y is 8. And 12, 0, x is 12, y is 0. That's out there. Here we go again. So now you're going to connect these two. Nope. Okay. Felt promising. Close enough. So this line here is line 2. Y is 8 minus 2 over 3x. And we can't forget about y equals 6. So what we said about y equals 6 is that, well, when x is 0, y is 6. When x is 2, y is 6. When x is 3, y is 6. So just kind of go up, do your best, and just draw a straight line across at 6. So this is line 3, y equals 6. Remember on our sheet, right, we had all these inequalities. Okay? If you just think about it for a second, all it's saying is that, okay, well, we have to be below this line. We have to be less than this line, and we have to be less than this line. But what I told you guys the trick is just start from the 0, 0, and just sprout out until you hit the first line, right? So when you hit a line, you stop, right? And that's your feasible set. So you just move out and sprout out to here. And then those are the points where you're going to find the points of intersection. Okay. So what I'm going to do here is just shade in the feasible set. These are all XY combinations that we could use that satisfy all those criteria that we had. Right? So this here is our feasible set. What step was that? We're on to step 4. Now that you have this area, right, you're going to identify and solve for all the points of intersection of the feasible set. So identify and solve for all the points of intersection of the feasible set. Okay. So 0, 0 is always an option. Doesn't sound that good. 0 x's, 0 y's. And what I do is I just label each of these intersections by a capital letter, as long as you label them with something. But I feel like capital letters are easy enough. All right, and so moving just from 0, 0, I just move around clockwise just to make sure I catch them all. Got to catch them all. A, B, C, D, and E. Notice what's nice about already having solved for 8, 0. You don't have to solve for it again, which it wouldn't be that bad, right, if you had to go back and solve for it. But now you've saved yourself a little bit of work. And same thing with 0, 6, right? You know that point. So you know A, you know B, and you know E, so we only have to solve for E and D. So what I'm going to do is just make a little table to summarize. So the point, I've got A, B, C, D, and E in terms of X and Y, A is 0, 0. B, we know from the graph, is 0, 6. C, and this is why it's helpful to label your lines, right? So C is the intersection of line 2 and line 3. So all I'm going to do for now is just jot down, okay, this is the intersection of line 2 and 3. Intersection of 2 and 3. D, same idea. D is the intersection of line 1 and line 2. Intersection of line 1 and 2. And E is at 8, 0. Or it's the intersection of line 1 and Y equals 0 if you had to solve for it. 8, 0, but I'll just put a note here. Would be the intersection of, what was it, line 1? 1 and Y equals 0 if we hadn't solved for it already, right? So depending on what value of X you might have picked when you were doing your points, maybe you haven't solved for it already. If we haven't solved for it already, but in our case, we've already solved for it, so we don't have to show it. So C is the intersection of line 2 and line 3. So line 2 was Y equals 8 minus 2 over 3x, and line 3 is Y equals 6. So to find the point of intersection, right, we're really just solving the system. But this one's nice because we know Y has to be 6, and so we just have to solve for the X that makes that happen. So they're both solved for Y, so we can just set them equal to each other, right? Cut out the Y, because we know it's 6 already. So we get 8 minus 2 over 3x is 6. Technically, using substitution, right? Substituting line 3, Y equals 6, into line 2. But that's the nice part of having them all solve for Y, because then we can just smush them equal to each other, and that is substitution. So now we're going to try to get, I didn't play my cards right there. I'm going to end up with some negatives, but not for long. So I want to get X on its own. So I have to go negative 2 over 3x is 6 minus 8. Yuck. Negative 2 over 3x is negative 2. I have to multiply both sides by 3 and divide both sides by negative 2. I can do that in one go if you want. X is 3. So C must be at 3, 6. Right, because we said y has to be 6. You can double check on your graph to see if that makes sense, right? But because we don't have a grid on here, and so we can't just go from here and say, oh, well, that's 3. It could be 3.1, right? You can't see that. So we can't actually just look at this point and map it down. We have to do the math, and you have to show the math. But yeah, 3, 6 looks pretty good to me. Right, so it looks like we're on the right track. How about D? D was the intersection of 1 and 2. So D is, equation 1 was y equals, what was it, 16? I've lost it. 16 minus 2x, I think. And 2, y was 8 minus 2 over 3x. Same thing. Substitute 1 into the other, solve for y already. And so we get 16 minus 2x is 8 minus 2 over 3x. We want to collect like terms, right? Bring the x's to one side, numbers to the other side, and eventually just boil it down to x's. So we're gonna have, which side do we want to bring it to? Maybe I'll do 16 minus 8 and negative 2 over 3x plus 2x. Hmm. 16 minus 8, that one's fine, 8. We have two options, right, to collect these two x's, collect like terms. We can pull out the common x, right, factor out the x, and then deal with our negative 2 over 3 plus 2, right? But either way, even if you keep the x's on there, you're going to have to find a common denominator, right? And so, because adding and subtracting fractions are tricky that way, right? Because we have to have the same bottom value. Right? And so I'm going to rewrite 2 as a fraction of 3. Right? So 6 divided by 3, for example, is 2. Right? So I'm just going to take something that turns into 2 and replace it by something that's divided by 3. And so I get negative 2 over 3x plus 6 over 3x. And just make a note here. 2 is 6 over 3. I'm just replacing it. Because now I can collect like terms, whether that be just pulling out the x's or just looking at the coefficients and saying, okay, well, that's going to be 6 minus 2 over 3. So we have 8 is just to show what I'm doing, I'll pull out the common x in front and do minus 2 over 3 plus 6 over 3. Because I know it's been a while since we worked with adding and subtracting fractions. Now we can, because we have the same denominator, we've got negative 2 plus 6 is 4 over 3. To solve for x, kind of home stretch here, we have to multiply by 3 and divide by 4. So we get 8 times 3 over 4 is x. I cheat and I say 8 divided by 4 is 2 and 2 times 3 is 6. And then just pesky habit, whatever I'm solving for, I like to finish with it on the left-hand side and the answer on the right-hand side. It doesn't matter. So then D, X is 6. I guess we don't know what Y is. I jumped the gun. That's okay, we can solve for Y. So now we have two formulas for Y. Either one will work, right? That's the whole point, is that they'll have the same X and Y solution. I'm gonna use the first one, because who likes fractions? Nobody. And so, solve for Y by saying, okay, equation 1 says that Y is 16 minus 2X, and X is 6. So then D is when X is 6 and Y is 4. And again, we can just look at our graph just to make sure that that makes sense. So D, yeah, sure looks like it could be around 6. Well, my drawing's not that good. That's why you can't rely on your drawing, right? But 6 and 4 looks reasonable. So now we have all our points of intersection. I forgot what step we're on. Anyone? Is that the one we just did, or? Oh, we are. Okay. Thank you. That was a long step. Step 5. You're going to list all the points of intersection and evaluate that P function that we have kind of forgotten about until now, right? And you're going to evaluate that P to figure out which one has the maximized value of P. Okay? So list all points of intersection and evaluate P. In this case, it's P equal to 2x plus 5y at each point. Pick the largest value of P. So the reason that we're finding all these points of intersection is just because, as a fact, P will be maximized at one of these points. Right? So we have to find what all these points are, evaluate P, and then we can pick the one that maximizes P. So we've got A, which is 0, 0. B, which was 6, 0? Is that right? 0, 6. Asleep at the wheel here. 0, 6. C, I even have it in front of me here. 3, 6. D, 6, 4. And E, 8, 0. I'm going to write P is 2x plus 5y up here. First one's easy. 2 times 0 plus 5 times 0. Fair enough. I don't really need to show any work there. How about 2 times 0 plus 5 times 6? Better. Rather have a profit of 30 than 0. How about 2 times 3 plus 5 times 6? 36. 2 times 6 plus 5 times 4? 32. Close. But so far, 36 is the one to beat. 2 times 8 plus 5 times 0? 16. So here we have it, folks. 36 is your maximized P. Woohoo! Therefore, P is maximized. Oops, maximized. Start over. To 36 at 3.6. Whoa, weird. Fluky. Oh, weird. And that's question 1. I know. It'll go way faster when you do it on your own, especially if you've done a few to practice, right? Any questions about that one before we forget it altogether? No? Yeah. Exactly. Yeah. Totally. So lots of steps, but as long as you follow those steps, you will be good to go. Hey, this one looks nice and tiny. Question 2. Maybe not. Well, it's not as big as the last one. I always want you guys to maximize stuff. What's the deal with that? Well, it's a good thing to know, I guess. Here we've just got a function, a polynomial, in fact, which we learned how to take the derivative of last day. And so we're going to maximize this function. And so the steps that we're going to follow when we're maximizing something like this is we're going to take the derivative of it. Right? The derivative is the slope of the tangent line. If we force it to be 0, then we're forcing it to be at the top of the peak. Right? And then we're going to solve for the x that makes that happen. That's your profit maximizing output, x. And then we can take that x and plug it back into the original formula to see what is your maximized function. Okay. All right, here we go. Again, I'm going to write down these steps. Step 1. Find the derivative of f of x. So f prime of x is how we denote the derivative. And if you weren't here last day, you might be panicking a little bit. Or if you were here, having nightmares. The derivative, what we do, right? Because this is all we need to be able to know how to deal with, right? Nothing bigger than this. Okay? And so what you're going to do is, I just imagine giving it a bump and all those powers decrease by 1, right? And fall down and multiply the coefficient in front. So basically, all these x's or all these values get demoted by 1. Right? And so what we end up with here is negative 125 times 2, right? Bringing that power of 2 down, times x, technically to the power of 2 minus 1, but if you just wanted to write x, that's fine, right? 2 minus 1 is 1. X to the power of 1 is just x. Plus 300, technically times 1. So I'll do my technical line, and then I'll show you what you could have just skipped to. Times x to the power of 1 minus 1. And then what we established was that the derivative of a constant, so just the number, just is 0. Okay. Or if you wanted to skip to this right away, negative 250x plus 300, that's fine too. So the coefficients change a little bit, or only for the first one really, right? But everything just kind of gets demoted, so our function gets smaller when we take the derivative. At least in this case. Sometimes it gets monstrous, but not for us. So that's step 1, taking the derivative. Okay. What I want you to do on the test, if for some reason you can't remember how to take the derivative, at least tell me that that's what you should do. Okay. And in general, if you just say, I don't know how to get that answer, so I'm going to use this equation instead, right, and follow through there, that's fine, right? You'll lose marks because you didn't know quite how to do the whole problem, but at least you'll be able to show me that you know how to do most of it, right? So if you're ever in the test and you're thinking, oh man, if I only knew that number, then just tell me, hey, I don't know how to find this, so I'm going to use 6x or whatever, right? That's worth something, knowing what to do if you had that number, right? So whatever you can do to show off how much you know is good. That's your job, right? So step 1, find the derivative. Great. Step 2, set the derivative equal to 0. And solve for x. So we know f prime of x is negative 250x plus 300. Force that to be 0. Negative 250x plus 300. Solving for x, right? I can move the negative 250 over. So I get x is 300 divided by 250, which I have is 1.2. Sounds right, but just check it. So what we've found is that f of x will be maximized at x equal to 1.2, right? That's not the value of f of x, it's just where f of x will be maximized. Okay. So f of x will be maximized at x equal to 1.2. So step 3 then is evaluate f of x at x equal to 1.2 in this case. Evaluate f of x at x equal to 1.2, or in general, the value from step 2. The value from step 2. So what we're going to do, so as long as you remember to put it into the original f of x, you're safe. F of x was negative 125x squared plus 300x minus 2. So f at 1.2 is negative 125 times 1.2 squared plus 300 times 1.2 minus 2. This I've got down as negative 180. Oh, I've got another step in here. If you skip to the next step, that's fine. But negative 125, I just want to show you 1.4 times 1.44 plus 300 times 1.2 minus 2. Now is negative 180 plus 360 minus 2, 178. So the maximized value of f of x is 178. Neato burrito? Good. Any questions about that one? Okay. On to the next one. This one's tricky, isn't it? Isn't it? This is one of those where we have to develop our own profit function. And so we're in the CVP analysis section of our formula sheet. So I can just make a note here. CVP analysis. If you don't have a copy of the formula sheet yet, I've got extra copies, but so just grab one after class maybe. You'll have the exact same one. I'll just have clean copies for you guys for the test. Can't have your own, fortunately. Okay. So there's a lot of information that we're given here, right? And so Ruth's milk carton opener, that's hard to say, costs $2 in materials. And each one takes 20 minutes to make at $30 per hour. Okay. So those two things make up the cost to produce each unit, right? That's your variable cost. Okay. So your variable cost, so step 1, or A, I guess, part A. We have a variable cost of 2x plus 20 minutes at $30 per hour. Oops, per hour. So we have to deal with that. Times x. All right. So this is the cost to produce 1 unit. So we can parking lot that for a little bit while we deal with these fixed costs, right? So we're given information on the variable cost and the fixed cost. And it'll be the same on the test, right? I'll give you information about the variable cost and the fixed cost. So the fixed cost is, so she's advertising for $30 per month and rent is $3,000. So the fixed cost is 30 plus 3,000. That one we can kind of deal with right away. Get a fun 30-30. Let's go back to this one. That's the trickiest one, I think. 20 minutes at $30 per hour. We have to convert 20 minutes to an hour, right? So 20 minutes over 60 minutes is an hour. Same units divided by the same units, but we know 60 minutes is an hour. That's not true. Snuck that by you. Otherwise, what I was saying was wrong. So 20 minutes divided by 60. Oh, I think I led you down the wrong path. I would just do 60 divided by 20 is a third of an hour. So a third of 30. That's why it ends up so nice. But now I'm down this rabbit hole. Let's see if it works out. 0.3. It doesn't. Make it an Etch-a-Sketch. Just delete it all together. Oops. Okay. Here we go. 20 minutes times $30 per 60 minutes. That's what I wanted to do. Late for me too, guys. I know, but this is your job. I know. So this becomes $30 times 20 over 60, which is just $10. But like I said, if you just thought about it, right? So if you didn't arrive at this math, that's okay, right? So if you just said in your mind, oh, well, 20 minutes is a third of an hour, so I could just divide the 30 by 3 to get to 10 minutes or $10, yikes. That's fine, right? You don't have to show the math for this part. As long as you get to 10, then that's good, clearly. So the variable cost is 2x plus 10x, which is 12x. Phew. So now we know our variable cost and our fixed cost. Part A is asking for find Ruth's profit function. So when you're finding a profit function, you're going to follow the same steps always, and you kind of just start in the bottom right-hand corner of the CVP analysis and just kind of work your way around those formulas, slowly filling in the blanks, right? Filling in the information that you know. And so we're going to start with the profit of X is the total revenue minus the total cost. We don't know either of those, so we have to keep going. The total revenue can be replaced by P times X. We don't know P. Remember, P is the amount that we're selling each unit for, right? So we don't know that amount. So that's okay. We just leave it as P. Minus the total cost, which can be replaced by the variable cost plus the fixed cost. Hey, finally something we do know. Right? So now we have PX minus 12X plus 30. So we have PX minus 12X, not forgetting about the negative on the 30 as well, right? When you open up those brackets, you have to bring that negative inside. So minus 30. Now we can collect like terms, right? The two X's can get put together. So X times P minus 12 minus 30. That's as far as we can go, right, until we know P. Any questions about that one so far? 3 for a loop with the $30 an hour. Threw me for a loop. It happens. Part B, we want to know what's Ruth's shutdown point. The shutdown point is just when P is less than C, right? So in our case, it's when P is less than 12. Remember, P is the amount that you're able to charge per unit. C is the cost to produce each unit. So if what you're selling it for is less than what it costs to produce it, you gotta shut it down, right? That's your shutdown point. And as far as what I'm looking for as an answer, if you just wrote this, that's it, right? 1 mark, done. C. If she sells the milk carton openers for $20 each, what's her break-even output? So now we're told, okay, she's selling these for $20 each. So P is 20 now. What's her break-even? Break-even output is when we go from negative profit to a positive profit, right? So when profit is 0, that's your break-even. So break-even means profit is 0. And I'll just jot down that P is now equal to 20. So we've got our profit function from part A. Profit of X is X times P minus 12 minus 30. Forcing the profit to be 0 and P to be 20, we can solve for X. So 0 is 20 minus 12 is 8x minus 30. Oops. Solving for x, we get 30 is 8x. So x must be 30 divided by 8. X is $378.75. So Ruth's break-even output is, well, let's think about this for a second, right? 378.75. If she only does 378 units, she's still got a negative profit, right? And we can't put out 0.75 of a unit. She can't say break off part of the milk carton opener and sell 3/4 of it. That just doesn't work, right? And so what we have to say is we have to push it to 379, right? 379 units. Okay. Must round up to the nearest whole value. Same idea, but now she actually wants to make some profit. If she wants to make $5,000 in profit, how many carton openers will she need to sell if she sells them at $20 each still? So part D, now we know that the profit of X is X times, you know what? Yeah, I'll just emphasize it. 20 minus 12. If you wanted to skip straight to 8X, that's fine, because the 20 stayed the same. Minus 30. Now I'm forcing this profit to be 5,000 is 8X minus 30. So now we'll move that 30 over to the other side. So I get 80/30 is 8X. So X is 80/30 divided by 8. X is 1,003.75. She must sell 1,004 units, right, by that same logic. If she only sold 1,003, she'd make a little bit less than 5,000. Right? So she has to push it to 1,004 if she wants to make at least 5,000. Any questions about that one? Okay. Let's see here. Monopolies. A monopolist has revenues given by, so the total revenue is 37x minus 3x squared, and total costs are 25x plus 9. So now you're given the total revenue and the total cost. And what's the monopolist profit maximizing level of output? So again, we're going to develop this profit function, take the derivative of it, because we want to maximize it. So we have to take the derivative, set it equal to 0, solve for X, plug that X back into the profit function. Just like that, you're done. So for this question, step 1 is going to be build your profit function. Build the profit function. So we've got profit of X is, from our formula sheet, the total revenue minus the total cost. But now we know what the total revenue is and what the total cost is. So the total revenue, we're told, is 37x minus 3x squared minus the total cost, which is 25x plus 9. Can simplify this. 37x minus 3x squared minus 25x minus 9. Careful when you're breaking out those brackets to bring in the negative inside. Collect like terms, you've got 37x minus 25x, and so we get, well, what is that? 37 minus 25. I get 12. So I have negative 3x squared minus or plus 12x minus 9. Step 2. This is where we can get into part A, right? But step 2 is find the derivative of the profit function. Well, we can make that its own step. Find the derivative of the profit function. So we know profit of x is negative 3x squared plus 12x minus 9. Just copying that down. So the profit prime of x, right, the derivative, these ones aren't that bad, so I'm just going to do it in one step, right? I get negative 6x plus 12. Have to bring that power of 2 down, multiplied by negative 3 to get negative 6, and then the x just disappears and the negative minus 9 just goes away. So part A is also step 3. Set the profit prime of x equal to 0 and solve for x. So again, I'll just rewrite profit prime of x is negative 6x plus 12. Force that to be 0 is negative 6x plus 12. So 6x is 12, so x must be 12 over 6. Must be 2. Worked out nicely. So then, the profit maximizing level of output, right, x is 2. So the profit maximizing level of output is x equal to 2. Part B, but also step 4, evaluate the profit of x at x equal to 2. This is back to the original profit function that we found. So profit of x, to remind ourselves, was negative 3x squared plus 12x minus 9. Negative 3x squared plus 12x minus 9. So the profit at 2 is negative 3 times 2 squared plus 12 times 2 minus 9. So then we have -3 times 4 plus 24 minus 9. 3 times 4 is 12. So 3 times 4 negative plus 24 minus 9. Get a measly 3. What? That's okay. Therefore, the maximized profit is 3. Any questions about that one? Oh. Next one. What you'll notice is that now these questions kind of get easier and easier, right? So that's nice. I put the hard ones at the end for this one, or at the beginning. Often what I find is that people like to work through a test in the order that it's given, right? And so if I put the easy ones up front, people tend to spend a lot of time on those when you should be spending time on the harder ones. So for this test, I just put the harder ones up front, and then they get easier as you go. So 2 parts. Find the equilibrium quantity and price for the following supply and demand functions. So we've got a system of equations. We have to solve for P and we have to solve for Q. So part A, we've got the supply curve is Q is 16P and the demand curve is 12, Q is 12 minus 2P. You can use substitution, or because they're all already solved for Q, you can just set them equal to each other. So you get 16P is 12 minus 2P. So we get 18P is 12, so P must be 12 over 18. Or if you prefer, 0.6 repeating. Solve for Q. You can use either of those equations. You can use either the supply curve or the demand curve to solve for Q, but I'll just use the easiest one. Q is 16P, where P has to be 12 over 18, right? Or if you use the decimal, that's fine too. So 16 times 12 divided by 18, I get a Q of, and we could write it properly, but I'll just do 10.66 repeating. Yeah.
Just out of curiosity, can you also do it under, like, I did under 2 over 3, because it was the 12. I ended up getting it different. I don't know if I got a different number, but I'm just wondering if the numbers that way.
It won't matter. No. Yeah, because they'll boil down to the same thing. Yeah. Cool. So, therefore, P is 0.66 repeating, and Q is 10.66 repeating. You don't have to wrestle with the fractions if you don't want to for this one. B, just steal it from here. The supply curve was that Q is 16P minus 8, and the demand curve was that Q is 16 minus 2P. Set these equal to each other. So we get 16p minus 8 is 16 minus 2p. Collecting our p's on one side, numbers on the other, we get 16 plus 2p is 18p, and then 16 plus 8 is 24. So p is 24 over 18. I'll just do p is 1.33 repeating. Q then, either one of these equations, I'll do 16p minus 8, why not? So 1.33, 16 times 1.33 repeating, minus 8. So times 16 minus 8, 13.33 repeating. Therefore, the equilibrium price is P equal to 1.33 and Q 13.33 repeating. Nice. Any questions about that one? A Dyson vacuum cleaner has a list price of $430 and trade discounts of 35% and 20%. What is the net price of the vacuum? So here seems too good to be true, right? We have the list price, we have 2 discounts, and we want to find the net price. That's all you have to do. So we're given that the list price is $430. The only thing you have to keep track of, right, is all this notation from the first part of your formula sheet, right? It's a little dicey. Discount 1 was 0.35 and discount 2 was 0.20. And we want to find N. Find a formula that works. N is L times 1 minus D1 times 1 minus D2. Looks pretty good. So we've got 430 times 1 minus 0.35 times 1 minus 0.20. We've got 430 times 0.65 times 0.8. Or if you wanted to just skip to it, that's fine too. $430 times 0.65 times 0.8. I get 223.60. Oops. Next question. If a jacket's sale price is $50 and the markdown is 40%, what was the original price? So here we're given the reduced selling price is $50 and the rate of the markdown was 0.4. And we want to find S. I have a formula that has all 3 and no more. That's pretty good. SR is S times 1 minus the rate of the markdown. The reduced selling price was 50. We're trying to find S, the original selling price, times 1 minus 0.4. So we've got 50 is S times 0.6. So S must be 50 divided by 0.6. The original selling price must be 83.33, repeating, doesn't really work. So the selling price must be $83.33. Any questions about that one? I think this one's so funny. Future Shop decides it wants a ROM U of 20% on the new iPhone 5. What's the GPM in percent? Okay. So let's just list what we've been given. Given that the ROM U has to be 0.2, the iPhone has to be 5. No. Find the GPM. Right. Luckily, we have the GPM, the gross profit margin, is the ROM U over 1 plus the ROM U. So it's going to be, what was it, 0.2 over 1 plus 0.2. So you've got 0.20 over 1.20. 0.166, repeating. Yes. Good. So the gross profit margin is 16.67%. Doesn't matter if you went to 1 decimal place or 2. Oops. Huh? I keep meaning to change this typo, but it also makes for a pretty funny question. A Sony 50-foot TV. I never remember to change it though. So a Sony 50-inch, obviously, TV sells for $1,000 with trade discounts of 15% and 35%. What is the list price? Okay. So let's see here. We're given N is 1,000. Discount 1 is 0.15. This one, when you're reading it, it's not obvious, right, that N is 1,000. The only reason that I jump for that is because it's asking for the list price. So the value that I'm given has to be the N, right? On the test, I've made it so that it's clear which one I'm asking for, right? Or it should be clear which one I'm going for. Right. So discount 1 is 0.15 and discount 2 is 0.35. So now we want to find L. We have N is L times 1 minus D1 times 1 minus D2. So we have 1,000 is L, which we're trying to solve for, 1 minus 0.15 times 1 minus 0.35. We've got 1,000 is L times 0.85 times 0.65. So 0.85 times 0.65, oops. You get L times 0.5525. So L must be 1,000 divided by 0.5525. So L is 1,809.954751. So L in dollars must be 1,809.95. We can do it. Any questions about that one? Pardon? Yeah, it's confusing, and that's what I mean. So this question wasn't that good. I just knew it had to be N because it's asking for the list price. I don't know. It's weird. It's a weird question. Here's the more important question. So we've got the same situation again. And now I want to know what single discount would be equivalent to this series of discounts, 15%, then 35%. Right? And so again, N is 1,000, which isn't obvious. D1 is 0.15, but it also actually doesn't matter for this question. D2 is 0.35. Because imagine if you didn't know this. We don't actually need to know that. We can just say that, well, we want to have a situation where L times 1 minus D1 times 1 minus D2 is the same as L times 1 minus D, right? And we want to solve for, find D. So you actually don't even need to know N or L to solve this problem, right? Because you can just, the L's cancel out. And then you're just left with 1 minus D1 times 1 minus D2 has to be 1 minus D. Here we have 1 minus D1 is 1 minus 0.15 times 1 minus 0.35, 1 minus D. We already solved this in the earlier question, so I'm going to sneak that in here and say, well, that's 0.5525, I think. Yeah. Has to equal 1 minus D. Solving for D then, I can get D is 1 minus 0.5525. So a single discount would have to be 0.4475. Therefore, a single discount of 44.75% is equivalent to discounts of 15% and 35%. That's not the same as saying 15 plus 35, right? Because it doesn't work that way. Okay. We'll just finish the last one. Last one. A restaurant marks up every menu item 20% of cost in order to cover overhead and 40% of the selling price for the profit. Overhead, we denote by E. Expenses, if you will. E is 0.20 times the cost. And the profit is 0.40 times the selling price. The steak and lobster dinner cost the restaurant, so the cost is $17.25. Find S. A nice place to start. S is C plus E plus P. And what I like to do is I just like to keep, even though I know C, I'm just going to keep it as a C and collect like terms until I can't anymore. S is C plus 0.20 C plus 0.40 S. So I get 1 minus, S minus 0.40 S is C times 1 plus 0.20. So I'm playing fastball here. So I get 0.60 S is 1.2 C. I know what C is. So now that I've boiled it down to 1 C, now I'm going to plug it in. If you'd plugged it in earlier, that's fine. So we get 0.60 S is 1.2 times 25. Oops. $20.70, so 0.60 S, making S must be 2070 divided by 0.6. So the selling price must be $34.50. Any questions? That's it. Yeah.
My question is, let me let you know, is that the last question is actually an example of the text. Because I was trying to see if I can look between the answers wrong on the text. And it was very confusing.
So that will happen. So if you're ever doing something and you're like, I am pretty sure this is wrong, just send me a picture because there are typos in the text. It happens. So yeah, that is good. All right. I guess I'll see you guys on the other side Monday.